All right, let's continue with the back page of Chapter 4, Review Worksheet number 2. Number 7 says find f prime if f of x is equal to the definite integral of square root of 1 minus t squared from 2x cubed to square root of x. So if we're trying to find the derivative of a function that has that's defined as a definite integral, then we have to use second theorem of calculus. Now, if you look at the bounds are both variables, so we have a second theorem of calculus adapted rule, which says that the derivative of a function from q of x to p of x is equal to, we essentially are taking advantage of the fact that we know the derivative and integral operations are going to cancel each other out. We just have to make minor adjustments by dealing with the upper and lower bounds. So we plug the upper bound into the function, so f of p of x, multiplied by the upper bound's derivative, minus, now we plug the lower bound into the function that we see, f of q of x, multiplied by the lower bound's derivative. Okay, so we'll do that here. I'm going to rewrite square root of x as x to the 1/2. Okay, so the derivative, we're simply going to follow the rule. So upper bound into the function, so square root of x goes in for t. So we have square root of 1 minus square root of t, square root of x, quantity squared, times p prime of x, so upper bound's derivative, x to the 1/2 becomes 1/2 x to the negative 1/2, right, minus, okay, so now we plug the lower bound into the variable that we see within the original function. So square root of 1 minus 2x cubed, quantity squared, times the lower bound's derivative, so 2x cubed becomes 6x squared. Okay, so we have our solution. We just have to clean this up. Okay, so 2 x to the negative 1/2, or 1/2 x to the negative 1/2, we can put this in the denominator as 2 times square root of x. And the square root of x squared, which the square root and the exponent is just going to cancel each other out, leaving us with just x. And then we have minus 6x squared times the square root of 1 minus 4x to the 6. So distribute the exponent through, and 3 times 2, anytime I have two exponents next to each other, I'm just going to multiply them. So 3 times 2 is 6. So we have our solution here. All right, number 7. Find f prime if our function is f of x equals the definite integral of square root of 1 minus t squared from 3x squared to pi. Now, remember, pi is a constant. So we're going to just use the original second theorem of calculus, where we only have to plug the upper bound into the function and multiply by the upper bound's derivative. But the lower bound is a constant. It will just eventually go away, and we don't have to worry about it. Okay. However, if we look at the problem here, this is not quite set up in the way that we need to apply. Well, it's not set up in the way so that we can apply the theorem directly. We're going to have to make some adjustments. We need the upper bound to be the one with the variable, so we have to switch. So we have to swap. So when we swap the lower bound with the upper bound, we're going to have to pull a negative out. Okay, so then once we have that, now we're in position to be able to apply the second theorem of calculus. So plug the upper bound into the variable. So we have negative square root of 1 minus 3x squared, quantity squared, times the upper bound's derivative. So 3x squared becomes 6x. And then we're left with negative 6x times square root of 1 minus 9x to the 4th. Okay. All right, let's look at number 8. Number 9, actually. So find the definite integral of the absolute value of x plus 2 from negative 5 to 6. So whenever you see absolute value function, whenever we want to find the integral, we can go through two methods. But either method, you're going to want to try and sketch the graph. So anytime you have an absolute value function, you know that your graph will be shaped like a V. Either V right side up or V upside down. Okay, so if you look at y equals absolute value of x plus 2, the vertex is at negative 2, 0. So negative 2, 0. and I'm just going to have my graph go. I know it's going to be right side up, so I'm going to just have my graph extend to my left bound and to my right bound. So my graph at -2 will extend and it will stop at x equals -5, and the other side will extend until x equals 6. So I'm always going to end up with two right triangles. Okay. These are also two linear equations. One is x plus 2 and the other is -x minus 2. So I can use this information to help me find the ordered pair at these corners. And these ordered pairs at the corners will help me identify the height of these triangles I'm going to add together. So if I plug -5 in for x, I'm going to get 3. If I plug 6 in for x plus 2, I'm going to get 8. So I can think of it as adding the areas of these right triangles. These are both above the x-axis, so my definite integral will just be two positive areas added together. Okay. Triangle area is 1/2 base times height. So 1/2 times base. Base is 3. My height is 3. Okay. For my second triangle, 1/2 base. Base is 8. You can count across to 8, and you see the base will be 8 units across. And the height will be 8. So 1/2 base times height. We add those two together, we get 9/2 plus 64 over 2, which gives us 73 over 2. Okay. Or, well, this is a solution. The other method that we could do it is we can think of it as the area under these two curves or these two graphs, and we can just find the definite integral of this region and this region. Okay, so for the first region, the definite integral of -x minus 2 underneath the -x minus 2 curve between -5, between the x values of -5 and -2. So this will give me this region. And then the definite integral of x plus 2 from -2 to 6. So I can go through power rule and find the integral that way. So go through power rule, -x squared over 2 minus 2x. That's a minus sign here. Evaluate between your upper and lower bound, plug in -2 in for the x, then do minus, then plug in -5. I didn't show all the work here, but this will come out to be 9/2. And then here, x squared, x plus 2 becomes x squared over 2 plus 2x. Evaluate between your upper and lower bound, plug in the 6 first, then minus, and then plug in the -2 in for all the x's. And I didn't show the work here, but this will come out to be 64 over 2. We add these together, we're going to get the same result here, 73 over 2. Okay. Number 10 is very similar. Absolute value of x minus 4. Vertex is at 4, 0. We extend the graph to the left and to the right until we reach our lower bound and upper bound, lower bound being -2, upper bound being 7. We have our two linear equations, -x plus 4 and x minus 4. Then we plug in the appropriate x lower bounds into the appropriate equations. We're going to get a y value of 6 here and get a y value of 3 when we plug 7 in for the x. And we go through the same steps. Find the area of both triangles, 1/2 base times height, 1/2 base times height. We're going to get 45 over 2. Okay, same thing, we can find the definite integral of these two regions from of -x plus 4 from -2 to 4, and then the definite integral of x minus 4 from 4 to 7. We go through power rule, go through and evaluate the upper and lower bounds, and we'll get the same solution that way, 45 over 2. Okay, number 11. If a of t is equal to 12t squared plus 18t minus 4, find and x of 1 equals 3 and v of -1 equals 9, find the below. So if we want to find the specific solutions, find the specific function for v of t, we can simply find the indefinite integral of a of t first. So go through power rule, and we're going to end up with plus c. So we have a general solution for v of t. Okay. Simply use the ordered pair from v of t to plug in. Plug 9 in for v of t, plug in -1 for t, and we're going to go through and solve for c. When we solve for c, we're going to get 0. And And so that's going to give us a specific solution of 4t cubed plus 9t squared minus 4t. Now, if I find the integral of v of t, that will bring me up to my position function. So that's the work shown here. We go through power rule again for integrals. And this time, I used a different constant. Instead of plus c, I used plus k, because I'm going through indefinite integral twice. Okay, so with this order pair, after I clean this up, I'm going to have t to the 4th plus 3t cubed minus 2t squared plus k. And I do have an ordered pair for my position function. So plug in 1 for t, plug in 3 in for x of t, and I go through and solve for k. Okay, I solve for k, I get k is equal to 1. So I have my specific function for x of t, t to the 4th plus 3t squared minus 2t squared plus 1. All right, finally, number 12. We have a graph of f of x below that consists of a semicircle, triangles, and a square. Find the average value of our function from -2 to 5. So average value, we know the formula there, 1 over b minus a times the definite integral from a to b of f of x dx. So we simply replace a and b with a is -2 and b is 5. So we're going to get 1 over 7 of definite integral from -2 to 5 of f of x dx. Now, because we're given this graph with geometric shapes, we can simply find the definite integral of f of x from -2 to 5 by simply finding the areas of these regions. Okay, so we have a triangle here, 1/2 base times height. Square, base times height was 1. Again, 1/2 base times height. Here, this region is a semicircle. So the formula for area of a semicircle is 1/2 pi r squared. My radius, the radius of the semicircle is 1. So 1/2 pi times 1 is pi over 2. But because this region sits below the x-axis, we have to say the definite integral value is -pi over 2. Again, triangle, 1/2 base times height was 1/2. Square is 1. So if we add all these values up, making sure that this is negative, we're going to have 1/2 plus 1 plus 1/2 minus pi over 2 plus 1/2 plus 1. All this combines to be 7/2 minus pi over 2, and I reduce that to be 7 minus pi over 2. Now this represents the definite integral from -2 to 5 of f of x dx. So I simply replace that in for with 7 minus pi over 2 times the 1 over 7. So really this is area divided by the width will give me the height. So average value is 7 minus pi over 14. Or you can split this up as individual fractions as 1/2 minus pi over 14. That will be fine as well.